In this video, I'm going to teach you how to calculate absolute uncertainty when given percentage uncertainty, and I'm going to use a question. This question is found in paper 2, and the first part of the question is you're asked to define velocity, because this one is straightforward. Velocity is change in displacement per unit time. So let's go to part B, which is the main part of the business of this particular question. The speed v of a sound wave through a gas of pressure P and density ρ is given by this equation here, where K is a constant that has no units. An experiment is performed to determine the value of K. The data from the experiment are as shown. So each physical quantity V, P and ρ are given with their percentage uncertainties. Now part 1 of B, you're asked to use the data given to calculate K. This is quite direct because all that you need to do is from this equation you can make K to be the subject. How do you do that? First of all, you can see this square root sign. So what you need to do is to square both sides of this expression in order to get rid of the square root sign. And that is where V squared comes in. And then you make K to be the subject by dividing both sides by P and multiplying both sides by ρ. And that is where you get this equation. K is equals to V squared ρ over P. And then you substitute in the values of V, of course remember to square it, the value of ρ and the value of the pressure, and you're going to get 1.353 as the exact calculation of this expression. But when we write down the answer, we must be careful to note the number of significant figures that are used in the actual physical quantities that were used to calculate it. For example, the number of significant figures of V is 2, ρ, we used 3 significant figures, and P, that is pressure, we used 2 significant figures. The rule is when we quote our final calculation, we must express the number of significant figures to be equal to the least number of significant figures that were used in the raw values. For example, we used 2, here we used 3, and here we used 2. So the least number of significant figures used in this calculation is actually 2. And that is why we are expected to express the final answer to 2 significant figures. Although an allowance can be given where that can be increased by 1, only 1. Don't go to this. So it would not be correct to quote your value like this. This would be the correct way of quoting your answer. Now let's go to the part which is the actual business of this question, how to calculate the absolute uncertainty in V. Again here, from the equation which is given here, K is equals to V squared ρ over P, we notice that the absolute uncertainty in K will be given by 2 times the absolute uncertainty in V plus the absolute uncertainty in ρ plus the absolute uncertainty in P. Now because we want percentage uncertainty, then we'll notice that the percentage uncertainty in K is equals to 2 times the percentage uncertainty in V plus the percentage uncertainty in ρ plus the percentage uncertainty in P. And that is what we have here. This is the percentage uncertainty in K, given by 2 times the percentage uncertainty in V plus the percentage uncertainty in ρ plus the percentage uncertainty in P. So when we substitute in the values, we are going to get that the percentage uncertainty in K will be 2 times 3%. 3% is the percentage uncertainty in V, plus the percentage uncertainty in rho, which is 4% according to the data, and then plus the percentage uncertainty in P, which was 2. All that gives us 12%. So we remember that percentage uncertainty in K, which is 100 times delta K over K, 100 times delta K over K is equals to 12. All right. So by substituting in the value of K here, and remember, we can use the exact value of K here. There is no problem. But the best would have been to use 1.4. 1.4. But even if you are to use the exact value here, you're going to get an answer which is closer to this one here, 0.16236. I calculated the exact value of the absolute uncertainty in K. Okay. Now, how does this value turn out to be 0.2? The rule is very simple. It follows that if we are uncertain about the fourth significant digit in this figure, there is no need writing the fifth significant digit. It follows that if we are uncertain about the third significant digit, there will be no need to write any other digits after the third one. That is not the end. So we can continue like that and argue out if we are uncertain about the first significant digit, there is no need to write the other significant digits because they are not significant at all. Okay? Because we are already uncertain about a higher significant digit. So the less significant digits are not worth writing down. That is why we always express absolute uncertainties to one significant figure. And that is why we will round up to one significant digit. So we concentrate on this, and then we look at this. If it's 5 and above, then we increase this one by 1. And that is how the absolute uncertainty in K becomes 0.2. Okay, it becomes 0.2. Now, the way we write the absolute uncertainty dictates the way we are going to write the value of K. We have already stated one of the rules that we use to get 1.4. It's just by looking at the number of significant figures that were used in the values that were used to calculate it. But here we are going to use the number of significant figures to which its absolute uncertainty is expressed to. It is expressed to one significant figure. Okay? And then we ask ourselves, which digit in the value of K does this absolute uncertainty affect? When we look at the value of K over here, which is I think it was 1.353, we realize that this digit affects this digit here, and that is why it would not be useful to write the other digits. It will not be useful to write the other digits in the value of K. So the digit which is affected by the uncertainty, by the absolute uncertainty, is this one here. We either decide to round it up or leave it as it is. In this case, we are going to round it up because 5, at least this digit is half. Okay, it's 5. If it's 5 and above, then we are going to increase this one by 1. And that is where it becomes 1.4 plus or minus 0.2. So this is the exact way in which k must be written down, because if you look at the question, we were asked to, let's look at this question here. We were told, use your answer in B part 1 and data from that figure to determine the value of k with its absolute uncertainty to an appropriate number of significant figures. And that is why the value of k must be written to two significant figures, okay, because the absolute uncertainty affects the second significant digit, okay. It affects the second significant digit as shown. Remember that the value of the uncertainty, affects the second significant digit, and that is why we must write k to two significant figures. I repeat that, it's very important. The value of the uncertainty in k affects the second significant digit in k, and that is why we must express k to two significant figures.